Off the coast of Scotland, you could witness this. Wind turbines being put into the water. They're called tidal turbines. They sit on the seafloor and harness the energy in the moving water that comes in and goes out with the tides. The potential is huge. It's estimated that we could practically capture enough tidal energy to power all homes in the United States twice over. Yet, at the moment, all the energy we get from existing tidal power plants worldwide can power less than 400,000 homes. So how does tidal power work exactly? And why isn't it everywhere yet? Tides are predictable. They come in, they go out, and they've been doing this the same way since the moon was born. So with the tides, stick a turbine in the water as it flows in or out, and voila, you can make electricity, with the same principle that wind turbines use. Moving water makes the turbine spin. This powers a gearbox and a generator, which turns mechanical energy into electricity. Water, incidentally, is over 800 times denser than air, which means that tidal turbines need to be sturdier, but they can be smaller and slower and still individually produce more power than wind turbines. Wind starts and stops blowing somewhat randomly, and the sun isn't always out. So these renewables can be difficult to integrate into the grid. Tides, as we know, are really predictable and consistent. So if batteries are charged when tides are flowing, we could use those batteries each time there's no movement and repeat at regular intervals. With tides, two main ways to extract power exist. One's called tidal stream and the other tidal range. Let's talk about tidal range power. That takes advantage of the difference between the high and the low tide, which can go up to 12 meters. And this kind of tidal power has been around for decades. The oldest tidal range generator, Laurence, was built in northern France in 1966. It cost around $1 billion in today's money, which is cheaper than a comparable nuclear power plant. There are 4 other tidal range plants running in South Korea, Russia, Canada, and China. Apart from geography, the infrastructure to support tidal range plants just doesn't exist everywhere. And people have opposed the massive structures because they can be horrific for the local environment, disturbing migratory fish, the composition of the soil, and even taking space away from local communities. 98% of tidal energy today comes from tidal range projects that together have a capacity of 520 megawatts, which is still a tiny fraction of our consumption. But the other kind of tidal power generation could shake things up. The younger and sexier kind of the market, tidal stream power. It's showing more promise at the moment with its simpler devices that depend on underwater currents caused by the tides. They vary in shape and design. And like wind turbines that have been known to cause the lungs of bats flying past to implode, the pressure difference caused by tidal barrages could have a similar effect on the internal organs of fish. But tidal stream projects are already more eco-friendly.
What we see is climate change is by far the worst enemy. So yes, these things will have environmental effects, but we should put them in that context of climate change.
Compared to wind or solar energy, tidal has been slow for a reason you might have guessed.
Sadly, a lot of the solutions are really expensive because the industry is so young. So it's a very small industry. It doesn't have an established supply chain or manufacturing chain. Corrosion is going to be a big problem. So you're going to have to choose your materials really carefully. Biofouling is a really big issue where, you put something in the water, things are going to want to grow on it and it's going to make it into a little mini reef, a little habitat. The performance of the turbine will deteriorate. So you need to find some way of preventing that. That's a huge operational cost.
Which is why most tidal stream generation projects cluster in the global north, where financial support to test the technology at this stage exists. China and South Korea are joining in, but lower-income countries like India have been slow or dropped plans to try out tidal power. But they could benefit when the costs of deployment begin to fall. So especially in coastal or island nations, tidal does have the power to play a significant role in getting to net zero in a relatively less disruptive way. The need of the hour is to make tidal power competitive.